Hello, you guys. Let's talk about negative and zero exponents. This is one of my favorite lessons all year, and you'll see me be really weird in class tomorrow. Okay, so here's the thing. Negative and zero exponents. For any non-zero number a, so a could be anything, anything to the zero power is always 1. I want you to think of the zero power as a special little superhero, and anything it touches instantly turns into the number 1. Okay? And then for any non-zero number a and any integer n, a to the negative power, okay, negative n power becomes 1 over a to the positive n power. Now, the way I help my students remember this is I ask them to think of a pool party, okay? And I want you to look over here at the pictures I imported. See this dad holding the baby, and the baby's all happy because he's in the pool. And see this mom holding the baby, and the baby's looking because the baby wants to get in the pool. I want you to think of the parent as the base number, the big number. And I want you to think the baby as a little teeny exponent, okay? And that'll help you understand my weird little story that I'm about to tell you. Okay, look at example 1. Write the expression using only positive exponents. So look at A. It's 4 to the negative 3 power. Now here's what's going on. 4 is the parent. It could be the mom or the dad. And the negative 3 is the crying baby. And the reason the baby is crying is because it wants to get in the swimming pool with everybody else. So my students a few years ago started saying, okay, let's draw a diving board, the fraction bar, and let's put a 1 in the pool. And then we're going to very carefully grab the parent and the baby and let them both get into the pool. Okay? The baby can't go by itself and the parent won't go by itself. They have to go together. So that gives us 1 over 4 to the third power. Now I want you to notice what happened to the baby. It became happy because it wanted to go in the pool. Okay, take a look at B. It's m to the negative 5th power times n to the 0 power. Well, the first thing I tell people to do is anytime you see that 0 power, think of it as the superhero baby, okay? So that baby is touching the parent n, so circle them, and that instantly turns into the number 1, okay? Anything the 0 power touches becomes 1. But now look at this parent m with the negative 5. Well, that baby wants to get in the pool. So draw the diving board, put a 1 in the pool. And now notice how I circled the m and the negative 5, and I drew an arrow to let them get in the pool. So my final answer becomes 1 over m to the positive 5 power. Okay, so take a look at example C. 13x y to the negative 8th power. Now the most important thing I can tell you to do is separate everything and show me the multiplication sign. Here's what I mean. 13 times x times y to the negative 8th power. Because here's the deal. 13 is a parent, but its baby is perfectly happy. They don't want to get in the pool. X is a parent, and its baby is perfectly happy. They don't want to get in the pool. The only parent, the Y, is holding the negative 8, and they're the ones that want to get in the pool. So draw the diving board, put a 1 in the pool, and then with your red, circle the Y to the negative 8th power, and let them carefully climb in the pool. So now we have 13x up on top, okay, put the fraction bar, and y to the positive 8th power in the pool, and box your answer. Okay, take a look at number 1. 33,333 to the 0 power. Well, anything the 0 power touches instantly becomes 1, and that's just the definition of the 0 power. Take a look at 2. 7 to the negative 3rd power. Well, this parent is holding a crying baby. So draw the diving board, put a 1 in the pool, and very carefully grab the parent and the baby and let them climb into the pool. So it equals 1 over 7 to the positive 3 power. You just made that baby really happy. Okay, take a look at number 3. 2z to the negative 2 power. So the first thing I tell people to do is separate it with this multiplication sign. So it's 2 times z to the negative 2 power. Well, remember, the 2 is perfectly fine to stay out of the pool. It does not want to get in the pool. But draw the diving board, put a 1 in the pool, and let the z and the negative 2 climb into the pool because that baby wants to go. So it's on top, we have the number 2 over z to the positive 2 power. You just made that baby happy. Okay, take a look at number 4. 3x to the negative fourth y. So first separate it. 3 times x to the negative fourth times y. And then draw your diving board, put a 1 in the pool. The only person that needs to get in the pool is the x with their crying baby. So circle the x with the negative 4 power and draw the arrow going down. So the 3y is still on top. Put your fraction bar. And then it's x to the positive fourth power. You just made that little baby happy. Okay, now look at example 2. This is kind of weird. It's rewriting fractions. Now they want us to write the expression without using a fraction bar. So here's what I would tell you. Get everybody out of the pool. Even if it's going to make the babies cry, you have to get everybody out of the pool. So look at A. It's 1 over 15. Well, what's happening here is it's 1 over 15 to the positive 1 power. Remember, put that 1 so you can see it. Now this baby is perfectly happy playing in the pool, but now we've got to say, no, 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 it's time to get out. So circle them and let them climb out of the pool. So now you have 15 to the negative 1 power. That baby did not want to get out. Over 1. Well, I made the over 1 in red because you can let that disappear, okay? Because we have to write it without the fraction bar. So think of everybody getting out of the pool. Okay, look at B. A to the third power over c to the fifth power. So leave the a to the third power alone, up out of the pool, but now grab c to the fifth power and let them climb out of the pool. So this becomes a to the third power times c to the negative fifth power, because that baby did not want to get out. Okay, take a look at the checkpoint. Write the expression without using a fraction bar. So everybody out of the pool. So it's 1 over 18. So I put 1 over 18 to the first power. I use my red. And then I grab the 18 and the power of 1 and I let them climb out of the pool. So guess what happens? It's 18 to the negative 1 power. That baby's going to start crying. It didn't want to get out. Take a look at number 6, 1 over 100. So the same thing, I put 1 over 100 to the first power down in the pool. And I say, okay, everybody out. So they climb out of the pool. So now it's 100 to the negative first power. That baby did not want to get out of the pool. Take a look at number 7, 3 over c to the second power. So grab the parent and the baby in the pool and let them climb out. So then it gives us 3c to the negative 2 power. Remember, the babies are not going to want to get out of the pool if they're happy in the pool. Okay, and then take a look at number 8, x to the fifth power over y to the seventh power. Again, circle the parent and the baby and let them get out of the pool. So it's x to the fifth power, y to the negative seventh power. Okay, look at example 3, using powers properties with negative exponents. So now we're going to use those tricks again. So look at A. It's 6 to the 12th power times 6 to the negative 4th power. Well, remember, when the bases match, copy the base, the 6, and then we just add the powers. So 12 plus negative 4 gives us 6 to the 8th power. Okay, take a look at B. 7 n to the negative 4th power over n to the first power. Well, I'm just going to copy the 7, and then I notice the bases match. And when the bases match, copy the base, the n, and then remember, when we're dividing, it's top minus bottom. Negative 4 minus 1. Okay, and then I added a line, changed the sign, so I get 7n to the negative 5th power. Well, remember, it's our job to make all those babies happy. So write it as 7 times n to the negative 5th power. And then draw your diving board, put a 1 in the pool, and then carefully grab the baby and the parent and let them climb into the pool. So that gives us 7 over n to the positive 5 power. Now take a look at the checkpoint. Find the product or quotient and write our answer using only positive exponents. So make all those babies happy. So take a look at number 9. 3 to the 10th power times 3 to the negative 7th power. Well, I noticed the bases match, so I copied the 3. And then remember, when we're multiplying, we just add the exponents. So 10 plus negative 7. And I wrote it right here, so that gives us 3 to the 3rd power. Baby's happy, I'm good. Okay, take a look at number 10. 7d to the negative 4th power over d to the 2nd power. So all I did was I copied the 7, and then I noticed that the bases match, so I copied the d, and since it's division, we have to subtract the powers. So it's negative 4 minus 2. So negative 4 minus 2. I added a line and changed the sign, So that gave me 7d to the negative 6th power. Well, I see that baby wants to get in the pool, so I draw the diving board, I put a 1 in the pool, and now carefully circle the parent and the crying baby and let them climb into the pool. So that gives us 7 over d to the positive 6th power.